Yeah, continuing from where we stopped. Now, sorry, I said something the other time. I just realized that like it's not proper. This one here, the way this one is formed, I just quickly show it again. Let me log this. Now, I was talking about how that one was formed, and like I saw that is not proper. The two hydrogen that will be added from ethanol CH3 CHO. So let me put it well. This should give us something like this, COH. So if you're adding two hydrogen, of course, to it, it's going to give us something like this, CH3. One of the H from here will actually attach to this H. This H you are seeing here, this one here is the one that we have here. While the second one will actually come to this place. So that's how it will be. So that's what I come to correct. So you can check the last video to see that I said mention something there, but this is the correct explanation. So now let's continue from where we stopped. We talk about the cyanide. The cyanide here is formed. Now the cyanide is undergoing continuous reaction. There's a continuous reaction here. Now it's reacting with dilute H2SO4. Before that, whenever alkanal is reacting with HCN, this reaction is called nucleophilic addition. And the nucleophile is cyanide with some nucleophilic addition. This one is called Victorian agents oxidation reaction. Now we dilute HCl. Now cyanide can actually undergo two kind of reactions that are peculiar. The first one is hydrolysis. Hydrolysis. In hydrolysis, what we use for reagents here is dilute acid. Now this dilute acid could be dilute HCl or dilute H2SO4. And whenever cyanide undergoes this hydrolysis, it must always produce carboxylic acid, as you can see here. The other thing is that it can also undergo what we call reduction. So now, when it's being reduced, the reagent for reduction always, as mentioned before, we have a. So this one, reduction action of hydrogen. In this case, you are adding 4 hydrogen to it because it's going to give you amine. So when nitrile is being reduced, you'll be having CH2 and NH2. And that you're having amine at the end of the day. So take note, cyanide, when they are being reduced, they give you amine. So in this case, we're having dilute H2SO4 plus it. So the reagent is actually H2SO4 condition is dilute plus it. So that to give you your full answer whenever you have a condition. Now, in this case, now our answer here is telling us to give us COH. There's no much work here. You have CH3, CH, bracket, OH. Then here you have COOH. That's the answer to that particular question there. So the next one we are having now is that this is also still reacting with conc H2SO4. As you see, concentrated H2SO4, looking at the product is saying that we have a double bond present. Double bond present. As the COH is showing, but also have double present. That means an elimination has taken place. That means that dehydration has also taken place. In this case, I mean, water is lost. So if I'm having CH3, I have CH, then I have CH here, then I have COOH. So looking at this place, and my OH is here, OH. Water is what? Lost. That means over this place, OH is lost from here and hydrogen from here. So this one will form what we call the double bond. So our answer is giving us what? Double bond. That's why we have it here. So conc H2SO4 leads to this. This is not part of the question, but from here you can get dilute. So in case you are asked in another question that what is the name of this reaction called when we have conc H2SO4, this is called elimination reaction, which gives us this water is being eliminated. So in this case now, this is now reacting with cold dilute MnO4. Obviously, carboxylic acid has nothing to do with cold dilute MnO4. What has something to do with this is the double bond. This double bond. So whenever it's reacting with cold dilute MnO4, It's going to give us a diol because in the reaction, you are going to be having CH2 double bond, CH, COOH plus H2O, then plus oxygen in this one. So all these two will be giving us OH and what? OH, which will now react. One of them will come here, the other one will come to this other side. So the answer to this is CH2OH, also CH2OH. Sorry, CHOH, rather, CH2OH. Then we have, that's how we have here. So I'm converting this one to a simple one now. So CH2OH, CHOH. Then you're having COOH at this place. That's what you are going to have. Now, this C now is undergoing Cl2. Now, this is Cl2O7, acidified Cl2O7. It's under reflux. Okay. Now, this reaction here is also called oxidation reaction. Oxidation reaction because the oxidizing agent, we have the acidified KMNO4. We have the acidified K2, I've mentioned it earlier before, K2Cl2O7. So oxidation here, also this one is called oxidation reaction. So reacting with this, that means that this is going to be oxidized. This is actually what we have here. So let me rub off this. What we have as C is actually what we are seeing here. So for it to be oxidized, it's going to you cannot oxidize carboxylic acid instead of oxidize the alcohol. Now this alcohol, what you do, whenever you have alcohol present, always check what kind of alcohol is this. Is it primary, secondary, or tertiary? This one is actually giving us two types. This first one is primary, the second one is secondary. So in that case, primary alcohol, we always give you alkanal, which you further oxidize to give you carboxylic acid. So whenever you have primary alcohol, you must always get carboxylic acid as your end product. But if you have a secondary alcohol, you're not going to get alkanone, that's ketone, as of end product. So this first one will be giving us COOH. Then this second one, this one here, this carbon will be giving us CO. Then we now have COOH. So this one we're having COOH. This one we have everything. So our final answer will be we have CCO, COOH, and we have OOH. So that's the answer to this question. So take note of that.